Okay, in this short video installment, we're going to be learning how to check multiplication by casting nines. I will assume you've seen my other two videos, but I will just review with you how to cast nines, and then we will proceed to showing how to check your multiplication problems by casting nines. Okay, casting nines is an old skill, but it's an easy one. We're going to take this 34 here and we're going to cast all the nines out of it. Subtract 9 gives 25, subtract 9 gives 16, subtract 9 gives 7. So when you cast nines from 34, you end up with a remainder of 7. And a shorter way to do that is simply add the digits. 3 and 4 add up to 7. And we're going to learn an even faster way here. This is all explained in my previous videos, but just in case you didn't see those videos, I'll explain it again here. Okay, 8,351. We're going to cast all the nines out of it, and we're going to use the shortcut by adding all the digits here. So 8 and 3 adds up to 11. 11 and 5 is 16. 16 adding one more gives 17. And then you have to keep going. We're going to cast nines from that, and we'll just add the digits and get 8. Now, once you're down to that 17, if you actually subtract 9, you'll also get 8, but we're adding digits here. Now, when you got longer numbers, you can actually look for pairs of numbers that add up to 9 and simply cross them off. There's a fairly obvious one here, 8 and 1. And if you add the remaining digits, you'll get the 8 that we had previously. So that was a lot easier. Now, sometimes you're looking for triplets. So if you take 5 and add 3 and 1 to it, you get 9. And then you can see the 8 just staring you right in the face. Okay, so let's cast nines from 2,735,648. Now, we certainly don't want to keep repeatedly subtracting 9 from it, but we can find the remainder when you divide by 9 by simply finding values that add up to 9 and casting them, or crossing them off. So 2 and 7 adds up to 9. 6 and 3 adds up to 9. 5 and 4 adds up to 9. So if you subtracted 9 repeatedly from that original number, you'd end up with just the 8. Okay, here's another example, and in this example I'm going to be looking for triplets and doublets. 2 and 7 casts because they add up to 9. And then the next 4 numbers in a row, I said triplets, but this one's going to be 4 numbers in a row, add up to 9. 4, 3, and 2 ones. They all add up to 9. If you think 3 and 4 is 7, and then the extra 2 ones there makes 9. And then 3, 3, and 3 adds up to 9. So when you're done, you just get this measly little 4 here. And that means if you took 2,374,113,433 and keep dividing it by 9, eventually you'd boil it down to just the number 4. Okay, so what does this have to do with checking multiplication? Well, it provides a very, very efficient way to check multiplication problems. You cast nines from the original 2 values. So in the top one here, 5 and 4 casts, and you get 7. And then if you take 23, add the digits, you get 5. And multiply them, 35. And keep going, add the digits, you get 8. That tells us our answer should also give 8. Let's see if it does. Okay, I think we can cross off 8 and 1, adds up to 9. And the remaining 3 digits here add up to 8. So we've done that one correctly. And notice that we're not having to redo the problem to check it. Okay, here's another one that supposedly is done correctly. Let's check it. 4 and 8 add up to 12, and in turn, the 1 and 2 and the 12 adds up to 3. All right, 5 and 3 adds up to 8, and that one's already ready to go. And it's a multiplication problem, so we're multiplying those. You get 24, but you keep adding digits whenever you get something bigger than 8. Anyway, 2 and 4 add up to 6. So we're hoping to get a 6 down here. And it's not hard to do. 5 and 4 cast because they add up to 9, and the remaining digits add up to 6. So that problem was done correctly. Okay, just for sake of completeness here, here's one where I've deliberately made a little mistake. There was a carry mark that I didn't pay attention to. That last digit where it says wrong really should be a 3. We're going to find out if our casting nines method will catch this mistake. Okay, on the top line up here, I can see that 6 and 3 casts, and the remaining digits add up to 7. 1 and 4 on the next line adds up to 5. And if you multiply those, you get 35. Add the digits, and you get 8. Okay, let's see if this gives 8 down here. The 9 casts outright. And the remaining digits, if you add them, 2 plus 2 plus 8 plus 4, they give 16. Adding those digits gives 7. So since we have a disagreement here, we know that the problem was done wrong. It unfortunately doesn't tell you what you've done wrong, but at least alerts you to the fact that something's amiss. Okay, one last example here. Let's check this problem. There's a lot of work to get this one done, but the answer of 290,115, we're going to try and find out if it's a valid answer. Okay, on the top line here, the 9 just casts outright, and you get 2 and 1 add up to 3. Across the bottom, you get 3 plus 1 plus 5. That adds up to 9, but that casts, so you get 0. And when you multiply 3 times 0, you get 0. So everything should cast down across this bottom so that we'll get that 0 that we're hoping for. Well, the 9 casts outright, and if you add the remaining numbers, 2, 1, 1, and 5, they cast. They add up to 9. And sure enough, you get 0. So that problem was done correctly. The answer that we kind of messed up here, 290,115, is a legitimate answer. Okay, so that's how you check multiplication by casting nines. Just to recap, you cast nines from the first two numbers, you multiply, and then that result, after you cast all the nines out of it, should agree with the cast nines version of your answer. Okay, so I hope this helps you check your work efficiently and quickly by hand.